Swayam Prabha. Digital India. Educated India.
Okay, now let us going to start with another idea is quadratic interpolation method. Quadratic interpolation method, it is useful to find the minimizing the step lambda star of the function f of lambda or f of x for which the partial derivatives with respect to the variable xi and not available or difficult to complete. So, this method finds the minimizing the step length lambda star in the stages, stage 1. In this stage, the vector S is normalized as follows: find delta which is equal to maximum of modulus of Si, where Si is the ith component of S, and divide each component of S by delta. Another method of normalizing is to find delta minus of S1 plus S1 square plus S2 square and so on Sn square whole power of, and divide each component of S by delta. Note, this stage is not required if one dimensional minimization problem has not arisen within a multivariable maximization problem. Stage 2, let h of lambda equal to a plus b lambda plus c lambda square be the quadratic function used for approximating the function f of lambda. So, the necessary condition for the minimum of h of lambda is that dh by d lambda equal to differentiate the given function, differentiating the given function, so that dh by d lambda equal to b plus 2c lambda equal to 0, and equating them, therefore, lambda star equal to minus 2 b by 2c. Therefore, the sufficient condition for minimum of h of lambda is d square h by d lambda square at lambda star is positive, that is c is positive. So, to evaluate the constant a, b and c, we need to evaluate the function f of lambda at 3 points: lambda equal to a, lambda equal to b and lambda equal to c be the points of at which the function f of lambda is evaluated, and let f of a, f of b, f of c be the corresponding function values, that is f suffix a equal to substitute lambda equal to a, therefore, a plus b a plus c a square will come, and then we have substitute lambda equal to a, we have a 3 equation f of a, f of b, f of c will come, and the solution of this equation gives a value, b value and c value we can determine with solving these 3 equations. So, that a equal to f a into b c of c minus b plus f b into c a of a minus c plus f c into a b of b minus a by a minus b into b minus c into c minus a. Similarly, for b and c also having the formula, we have to solve the simultaneous equation. From the above 3 equations, the minimum of h of lambda can be obtained as lambda star equal to minus b by 2c, and b you know, c you know, substitute it, so that f a of b square minus c square plus f b of c square minus a square plus f c of a square minus b square by twice of f of a into b minus c plus f b of c minus a plus f c of c a minus b, provided that c as given the equation c is positive. To start with, for simplicity, the points a, b and c can be chosen as 0, t and 2t respectively, where t is presented, that is pre-select the trial steps length. By this procedure we can use one function evaluation, since Fa equal to f of lambda equal to 0 is generally known from the previous iteration. For this case, the following above equation reduced to A equal to f of A and B equal to 4 f of B minus 3 f of A minus fc by 2t, and C equal to fc plus fa minus 2 fb by 2t square, and lambda star equal to 4 fb minus 3 fa minus fc by 4 fb minus 2 fc minus 2 fa into t, provided that C equal to fc plus fa minus 2 fb by 2t square, which is positive, and this inequality of C can be satisfied if f of A plus f of C by 2 equal greater than fb. That is, the function value of fb should be smaller than the average value of f of A and f of fc. So, this can be satisfied if f of b lies between the line joining f of A and fc as shown in the figure. So, fb is smaller than f of A and f of c, therefore, take the average by 2 so that fb will come, and the following procedure can be used to only to satisfy the inequality of f of A plus f of c by 2 is greater than f of b, but also to ensure that minimum lambda stars lies between the interval 0 to 2t of lambda star, and we have a cases assuming that f of A equal to f of lambda equal to 0, and the initial step size to t naught are known to evaluate the function at lambda equal to t naught. So, f1 equal to f of lambda equal to t naught. So, the possible outcomes are shown in the figure, that that is A2 lambda star fa, f1 lies between to f of A and corresponding lambda star, and fa in between lambda A, lambda star is in between A to t naught and corresponding the value here t naught corresponding value here lambda star corresponding value here, f of A and f1. So, this is the meaning of the possibilities of the outcomes, and if f of 1 greater than f of A and is realized the third picture set fc equal to f1, and evaluate the function f at lambda equal to t naught by 2 and lambda star using the equation t equal to t naught by 2. If f1 is less than or equal to f of A is realized 2 and 3 or 1 and 2, set fb equal to f of 1 and evaluate the function f at 2 t naught to find f2 equal to f at t lambda equal to 2 t naught. This may result in any one of the situations shown in the figure, right. F1, 2, 3, 4 x demonstrated like this. If f1 lies between fa and f2 and f1 is lies between fa and f2 and f1 lies between fa and f2 and t naught is lies between a to 2 t naught. So, these are all the situation may arise, and if f2 turns out to be the greater than f1 and fc equal to f2 and compute a lambda according to the equation t equal to t naught. If f2 turns to be the smaller than f1, set f1 and f2 are equal and t equal to 2 t naught, and repeat the step 2 to 4 until we are able to find a lambda star. Stage 3, we have to make the score that this lambda star is sufficient close to the true minimum of lambda star, and before taking lambda star is approximately equal to lambda tilde star. One possible test to compare of f of lambda star with h of lambda star, and consider lambda star is a sufficient and good approximation. if they differ not more than a small amount of h of lambda star minus f of lambda star by f of lambda bar star is less than or equal to epsilon. So, another possible test to examine whether df by d lambda is close to 0 at lambda star. So, we can use a finite difference formula for df by d lambda and use the criterion to stop the procedure. So, f of lambda star plus lambda delta star minus f of lambda star minus delta lambda star by 2 delta lambda star is less than or equal to epsilon 2. So, if the convergent criteria are not satisfied, the new quadratic function is used to approximate the function f of x or f of lambda. Now, h star of lambda is equal to a dash plus b dash lambda plus c dash lambda square. So, to evaluate the constant a dash, b dash, c dash, the three best function values current f of a equal to f of lambda equal to 0, f of b equal to f of lambda equal to t naught, f c equal to f of lambda equal to 2 t naught, and f tilde equal to f of lambda equal to lambda bar are to be used. So, this process of trying to fit another polynomial to obtain better approximation to lambda star is known as refitting the polynomial. So, this theory you have to understand first, then let us go to solve the problem. Now, refitting the scheme having the condition case 1, the characteristics lambda star tilde greater than b and new a and old b and f tilde less than fp corresponding the new abc neglect old a and old b lambda star and c arrived. New points for refitting. For second case lambda star del tilde is greater than b and f tilde is greater than fp corresponding abc neglect old c, therefore, the old a b tilde delta lambda delta star comes. If lambda tilde star is less than b and f tilde is less than fb corresponding a b c neglect old c and a lambda bar star b will come. And fourth, we have a lambda star tilde less than b f bar greater than fb. So, abc and neglect old c and corresponding old refitting of lambda bar bc generated. Now, let us go with one example. Find the minimum of f equal to lambda power 5 minus 5 lambda cube minus 20 lambda plus 5. The solution is, this is not a multivariate optimization problem. We proceed directly to the stage 2. Let the initial step size is taken as t naught equal to 0.5 and a equal to 0. So, fa equal to f of lambda equal to 0, substitute in this equation. Substitute in this equation, we have fa equal to 5 and f1 equal to f of x equal to t naught is 0.5 and substitute in the given function. So, that 0.03125 for lambda power 5, 5 into lambda q is minus 0.625 and 20 into lambda is 0.5 is minus 10 plus 5 equal to minus 5.59375 will come. Now, compare f1 and fa, f1 is less than fa, so we set fb. So, fb equal to f1 which is equal to minus 5.59375. Now, to find f2, so f2 is the rule is f of lambda equal to 2 t naught. So, 2 into t naught is what 0.5 which is equal to 1 and substitute f of 1 in the given equation. Given equation 1, therefore, it becomes 1 minus 5 minus 20 plus 5 equal to minus 19. Now compare F2 and F1. F2 is less than F1, therefore set new T naught equal to 1 and F1 equal to minus 19. Again we find F1 and FA. F1 is less than FA, therefore set FB equal to F1 equal to minus 19. Now F2 equal to lambda equal to 2 T naught equal to T naught is 1, therefore 2 into 1 is 2. Therefore, f of 2 substitute in 1, therefore minus 43 will come. Then compare with the F2 and F1, F2 is less than F1. We again set T naught is equal to 2 and find F1. F1 is minus 43. Compare with F1 and less than FA. So, FB equal to F1 equal to minus 43. Now, evaluate F2. F2 equal to F of lambda equal to 2 T naught and corresponding value 629, and compare this F2 and F1. F2 is greater than F1, hence F naught equal to F2 equal to 629 and compute lambda star. So, FB we know that, FA we know that, FC you know that, so it is FC. So, once you got it FC, therefore, we have the direct formula of lambda star equal to 4FB minus 3FA minus FC by 4FB minus 2FC into minus 2FA into star of T. So, T here is 2 T naught, that is T naught is 2. FA, FB, FC you know the value, substitute it. So, we have 1.135 will get it. Now, we have a convergence test. A equal to 0, F of A 5, B 2, FP equal to minus 43, C equal to 4 and FC equal to 629. So, the values of A, B and C can be found to be A equal to F of A equal to 5 and B formula 4FB minus 3FA minus FC by 2T, and substitute here you get minus 204, that is a B value, and C equal to FC plus FA minus 2FB by 2T square, which is equal to 629 plus 5 minus 2 into FB is minus 43, therefore, the net value is 90. Now, h of lambda star tilde is equal to h of 1.135, which is equal to A plus B lambda plus C lambda square. Lambda you know the value, substitute it, you can get the value of h of lambda star tilde equal to minus 110.599. Therefore, f tilde equal to f of lambda star tilde equal to what? 1.135 whole power 5 minus 5 into 1.135 whole cube minus 20 into 1.135 plus 5, which is equal to minus 23.127. So, now you go to the iteration 2. Since lambda star tilde is less than B and f tilde greater than FB, so we take a new values of A and B. Therefore, A equal to lambda star tilde equal to 1.135. So, FA equal to minus 23.127, B 2, FP got it, C 4, FC equal to 629. Now, lambda star tilde is equal to FA into B square minus C square, FB into C square minus A square plus FC into A square minus B square, and then divided by 2 into FA of B minus C plus FB into C minus A plus FC into A minus B. You know all the value, all the data, substitute it. So, for FA we have minus 23.127 into B square minus C square is 2 square minus 4 square. minus 43 into 4 square minus 1.135 the square plus 629 into this divided by twice of minus 23.127 into 2 minus 4 minus 43 into 4 minus 1.135 plus 625 into 1.135 minus 2. So, we have minus 2060.7888 divided by what? Minus that is 12 12,442.052, divide them, we have 1.659 will come. Now, based on this value, we have to do convergent test. So, the rule is FA into B into C of C minus B plus FB into CA into A minus B plus FC into AB into B minus A by A minus B into B minus C into C minus A. You know all the value of A, B, C, FA, FB, FC, substitute it. You have 1424.346 by 4.95645, which is equal to 287.372. Also, we have a B equal to FA into B square minus C square plus FB into C square minus A square, FC into A square minus B square by A minus B into B minus C into C minus A, which is equal to minus 415.779 and C equal to minus FA into B minus C plus FB into C minus A plus FC into A minus B by A minus B into B minus C into C minus A. So, we have 125.29. Therefore, H of lambda star is equal to H of 1.661 equal to 287 into 372 minus 415 into 779 into 1.661 plus 125.29 into 1.661 the whole square, which is equal to minus 57.57. So, that F tilde equal to F of lambda star tilde is equal to given equation, you substitute it. So, that 1.661 the whole power 5 minus 5 into 1.661 cube minus 20 into 1.661 plus 5 and simplify, you get this value, that is 12.6429 minus 22.9128 minus 33.22 plus 5 equal to minus 38.489. Therefore, H of lambda star tilde minus F of lambda star tilde by F of lambda star tilde is equal to 0.4957. So, this quantity is not sufficiently small and we have to proceed to the next refit. Next example, find the minimum of the function f equal to lambda by log lambda by the following quadratic interpolation method. Quadratic interpolation method. So, take the initial trial steps length as 0.1 and T naught equal to 0.1 and A equal to 0. So, FA equal to F of x equal to 0, which is equal to 0, and F1 equal to F of x equal to T naught, and T naught equal to here the value of T naught equal to 0.1, substitute F equal to 0.1 by log 0.1, which is equal to minus 0.1, and since F1 and FA, F1 is less than FA, so we have to set FB equal to F1 equal to minus 0.1 and find F2 equal to F of lambda equal to 2 T naught, which is equal to 0.2 equal to minus 0.2861. So, as F2 is less than F1, we set now nu to T naught is 0.2 and F1 equal to 0.2861. Again find F1 and FA, F1 is less than FA and hence FB equal to minus 0.2861 and find F2. F2 is lambda of 2 T naught. T naught is 0.1 you know, I substitute it so that lambda equal to 0.4 will come. So, F2 of 0.4 is lambda by log T, log lambda, that is lambda is 0.4 by log 0.4 which is equal to minus 1.0051, and since F2 is less than F1 we again set T naught equal to 0.4 and F1 equal to minus 1.0051. Therefore, FA and compare with F1 is less than FA and set FP equal to F1 equal to minus 1.0051. Find F2 equal to F of lambda equal to 2 T naught. T naught is 0.4, 2 into 0.4 is 0.8 and substitute in the given function lambda by log T equal to minus 8.255. Compare with F2 and F1. F2 is less than F1, we again set T naught equal to 0.8 and F1 equal to minus 8.255 as this F1 is less than FA. So, FB equal to F1 equal to minus 8.255. Therefore, F2 equal to F of lambda equal to 2 T naught which is equal to 7.838. So, this time F2 is greater than F1 and hence no set Fc minus F2 equal to 7.838 and compute lambda star tilde. So, here F of A equal to 0 and Fp got it, Fc also we got it, right. So, T naught equal to 0.8. So, we know Fa, Fb and Fc and substitute what lambda star tilde equal to 4Fb minus 3Fa minus Fc by 4Fb minus 2Fc minus 2Fa into T. So, we have the value of Fb, Fa, Fc, substitute it so that 4 into minus Fp is minus 8.255 and then Fa is 0 and Fc is 7.838 divided by 4 into minus 8.255 minus 2 into 7.838 minus 0 and here multiplication into 0.8. So, numerator is minus 40.858 and denominator is minus 48.6986 and cancel negative into 0.8 equal to 0.6712. Now, we have to do with the convergent test. A equal to 0, Fa equal to 0 you know already found, B got it, Fb got it, C got it, Fc got it. Now, the rule is A equal to Fa, Fa is 0 therefore, A is 0, B equal to 4Fb minus 3Fa minus Fc by 2T which is equal to 4 into minus 8.255 minus 3 into 0 minus 7.83 by 2 into 0 which is equal to minus 25.536 and C equal to Fc plus Fa minus 2Fb by 2T square which is equal to 7.838 plus 0 minus 2 into minus 8.255 divided by 2 into T square. T square is T is what? 0.8. So, 0.8 square, substitute it, 19.0218 will come. Therefore, h of lambda stars tilde is nothing but h of 0.712, and you know the equation quadratic quadratic equation a plus b lambda plus c lambda square. Now, a is 0 and b is you found out minus 25.536 into lambda. So, lambda is 0.6712, this is lambda, and then C 19.0218 into lambda square is 0.6712 whole square. Simplify, you have minus 8.5702, and now f tilde equal to f of lambda star tilde, which is equal to lambda by log lambda. Lambda is 0.6712 by log of lambda is 0.6712 equal to minus 3.876. Therefore, the rule is h of lambda star tilde minus f of lambda star tilde by f of lambda star tilde equal to minus 8.5702 plus 3.8765 by minus 3.8765 equal to 1.21. Now, iteration 2, compare with the b and f of b, lambda star is less than b and f tilde is greater than f b. So, we take a new value of a, b and c. So, a equal to lambda star tilde equal to 0.6712 and fa found out already, and b equal to 0.8 and fp found out, c 1.6, fc equal to 7.838. Now, the formula for finding the iteration 2 lambda star tilde equal to fa into b square minus c square plus fb into c square minus a square plus fc into a square minus b square by twice of f of a into b minus c plus f of b into c minus a plus fc into a minus b. We know all the values of b, c, fa, fb, fc and a. So, that substitute in this equation. So, the net answer is, for the numerator we have minus 11.456 divided by minus 11.151, which is equal to 1.027. Now, making use of this, we have to test the convergency. So, the rule for convergency is a equal to fa into bc into c minus b plus fb into ca into a minus b plus fc into ab into b minus a divided by a minus b into b minus a into c minus a, and you know the value of abc and fa, fb, fc also you know. Substitute it and the numerator is 4.8065 by 0.09540. Divide them, we have 50.22 is a value of a, and then go ahead with b. B is fb into b square minus c square plus fb into c square minus a square plus fc into a square minus square by everything divided by a minus b into b minus c into c minus a, and substitute all the values of a, b, c, fa, fp, fc. So, that we have 11.456 by 0.0957 equal to minus 119.709, and for convergence test corresponding c is minus fa into b minus c plus fb into c minus a plus fc into a minus b by a minus b into b minus c into c minus a, and substitute the values of a, b, c, fa, fp, fc. So, that we have 58.261. For h lambda star square is equal to a plus b lambda plus c lambda square. So, this implies lambda equal to 1.027 and then A value is what? Already we found out A value is 50.22, A value you know 50.22, and B value into lambda is minus 119 into 0.709 into 1.027, and C value 58.261 into lambda is 0.1027, right, the whole square, and then we have minus 11.2715. Therefore, F equal to F lambda star tilde equal to 88.76. Therefore, H of lambda star tilde minus F of lambda star tilde by H of lambda star tilde equal to minus 11.275 plus 88.76 by 88.76 equal to 0.876 is a convergency value. That is a required answer to the problem. Next example, minimize the function f equal to x1 minus x2 plus 2x1 square plus 2x1 x2 plus x2 square, starting the point x1 equal to 0 0 along the direction minus 1 comma 0 using the quadratic interpolation method with the initial step length of 0.1. So, f is given here to be determined x1 x2. So, the rule is x1 plus lambda s, x1 is 0 0, lambda into s is minus 1 comma 0, therefore 0 minus lambda 0, and then net value minus lambda comma 0, therefore f of lambda is f of minus lambda comma 0. It means x1 is minus lambda, x2 equal to 0, substitute in equation 1. So, that minus lambda minus 0 plus 2 times of minus lambda square plus 2 into minus lambda plus 0 plus 0, which is equal to f of lambda equal to minus lambda plus 2 lambda square equal to 2 lambda square minus lambda. Now, we have a iteration 1, fa equal to f of lambda equal to 0 is 0, and f1 equal to f of lambda equal to t naught, and substitute in the given function 1. So, that 2 into minus 1 the whole square plus minus 0.1 equal to minus 0.08. Now, compare f1 and fa, f1 is less than fa, set fb equal to f1 equal to minus 0.08, and find f2, f2 equal to f of lambda equal to 2 t naught equal to 0.2. So, 2 into this function will come because of the equations, right. This is the 2 lambda square minus lambda. So, that this value will come and this value also generated. Now, f2 is less than f1. So, we set a new t naught equal to 0.2. Now, f1 equal to minus 0.12, again we set f1 less than fa. So, fb equal to f1 equal to minus 0.12. So, find f2, where f2 equal to f of lambda equal to 2 t naught equal to 0.4, and substitute in this second equation. So, that f2 may generated. Now, check with f1 and f2, f2 is greater than f1, and hence fc equal to f2 equal to minus 0.08 and compute lambda star. Now, we got a value, fa value, b value, fb, c value, fc value. Once you know all the value, then substitute lambda star tilde equal to 4 FB minus 3 FA minus FC by 4 FB minus 2 FC minus 2 FA into star T. Therefore, 4 times of minus 0.12 minus 3 times of 0 plus 0.08 by 4 into minus 0.12 minus 2 into minus 0.08 minus 0 into 0.2, which is equal to 0.4 by minus 0.32 into 0.2 equal to 0.25. Now, for the conversion test, A equal to FA equal to 0 and B equal to 4 FB minus 3 FA minus FC by 2T. FA no, FB no, FC no and T no, substitute it, you get B value minus 1 and C equal to FC plus FA minus 2 FB by 2T square, 2T square. So, we have 2. Now, H of lambda star delta equal to H of 0.25, which is equal to A plus B lambda plus C lambda square. Lambda equal to 0.25, A is 0, B is minus 1, C is 2, substitute it. So, that H of 0.25 equal to minus 0.125. Therefore, F tilde equal to 2 into 0.25 the whole square minus 0.25 equal to minus 0.125. Therefore, convergency you have to check H of lambda star tilde minus F of lambda star tilde by F of lambda star tilde equal to minus 0.125 plus 0.125 by minus 0.125. So, exactly 0 is coming and beautifully it is converges, hence the problem.